Hey class, in today's lesson we're going to talk about trigonometric functions, the unit circle, which is found in section 4.2 part 2. Our objectives are to evaluate trigonometric functions using the unit circle, to use a domain and period to evaluate sine and cosine functions, and to use a calculator to evaluate trig functions. So in example 2, we're going to evaluate the trigonometric functions at 0 equals negative pi over 3. The only difference between this and what we were doing in our very last lesson is that this one now involves a negative radian. So in order for us to kind of stay within the unit circle, we know that we really only talk about positive values. So what we need to do is determine what negative pi over 3 is as its coterminal point. So to find a coterminal point, remember all you do is add 2 pi. So if I have negative pi over 3, and I add 2 pi to that, and again, I need a common denominator, that'd be negative pi over 3 plus 6 pi over 3, and that gives us 5 pi over 3. So to find the 6 trig functions of 5 pi over 3, now at least I know where it is. Okay, a pi over 3 is a 60-degree angle. And 5 pi over 3 is very close to 6 pi over 3, which lets me know that it's in the 4th quadrant. So it's somewhere over here. Okay, since it's in the 4th quadrant, and we know like all students take calculus, that means that cosine is the only thing that's positive over there. So as a since it is a 60-degree angle, that means its cosine is 1/2 and the sine is negative square root of 3 over 2. Okay, so then we go from there and we find all the 6 trig functions. So if I start with sine theta is negative square root of 3 over 2. Cosine theta is 1/2. Tan theta would be negative square root of 3 over 2 divided by 1/2, which is the same thing as negative square root of 3 over 2 times 2. The 2's cancel, so I'm left with negative square root of 3. Okay. The cosecant theta, which is the reciprocal of sine, would be negative 2 over square root of 3, but I have to rationalize that. So it gives me negative 2 square root of 3 over 3. Cosine is secant theta. The reciprocal of 1/2 is 2. And the reciprocal of tangent theta would be cotangent theta. Really, that was negative square root of 3 over 1. So this is 1 over negative square root of 3. But I have to multiply by square root of 3 over square root of 3 to rationalize it. So it gives me negative square root of 3 over 3. And we are done. All right, so domain and period of, that's supposed to say sine and cosine. So it says the domain of the sine and cosine functions is the set of all real numbers. The domain of these functions is negative 1 to 1. Adding 2 pi to each value of t in the interval 0 to 2 pi completes a second revolution around the unit circle. Functions that behave in such a repetitive or cyclic manner are called periodic. We'll talk more about this a little bit later on, but right now, all we need to really know about is trying to find something that's coterminal. So I kind of jumped the gun on that one by adding the 2 pi in the last problem, but now we understand why. So anyway, so to evaluate the sine and cosine of 13 pi over 6, first of all, 13 pi over 6 is larger than 1 unit circle, right? Because 2 pi, the equivalent to 2 pi with the denominator of 6 would be 12 pi over 6. So 13 pi over 6 is just a little past 12 pi over 6. Now I can either use logic in knowing what quadrant it falls in, or I can mathematically figure that out. And again, I would rather mathematically figure it out just so that I can be sure for sure what quadrant it falls in. So again, 13 pi over 6, I need to subtract a full revolution. So I need to subtract 2 pi. Again, with a common denominator, that would make this 13 pi over 6 minus 12 pi over 6, which I just mentioned. And that gives me pi over 6. And again, pi over 6 falls in the first quadrant. So that lets me know pi over 6, by the way, is a 30-degree angle. And what I know about a 30-degree angle is that sine of 30 is 1/2. So the sine is 1/2, so that makes this square root of 3 over 2. And in first quadrant, all trig functions are positive, right? So if I wanted to find the sine and cosine, here they are. Sine of 13 pi over 6 is 1/2. And cosine of 13 pi over 6 is the square root of 3 over 2. And we're done. Again, we're going to go ahead and try to evaluate the sine and cosine of negative 7 pi over 2. Again, negative 7 pi over 2 is way too far. First of all, it's negative, so we don't want to even deal with the fact that it's negative. So we're going to add 2 pi to that. So if we add 2 pi, it needs a common denominator, so I'm going to multiply by 2 over 2. So that's negative 7 pi over 2 plus 4 pi over 2. However, it's still negative. I get negative 3 pi over 2. So again, I need to take that negative 3 pi over 2, and I need to add another 2 pi or 4 pi over 2, right? And that gives me now pi over 2. And I know that pi over 2 is actually the 90-degree angle. And as an ordered pair, that is 0, 1. So sine of negative 7 pi over 2 is 1, and cosine of negative 7 pi over 2 is 0. And I put those in parentheses because we typically, if it's a negative angle, we like to put those in parentheses. All right, one more. Okay, so on these are not too bad because we use the calculator on these only. So if you want to find sine or cosine or cotangent or whatever of a particular radian, what you would do is you'd have to make sure that your calculator's mode is in radians. Otherwise, the default, is in degrees. So in my calculator, what I would type on this one, after changing the mode to radians, I would type sine, parentheses, 2 pi divided by 3. And what I would get is about 0.866. For cotangent, what I would do, because there is no cotangent function, you would have to do the reciprocal. So remember, the reciprocal of cotangent is tangent. So that'd be 1 divided by tan of 1.5. Or you can do tan 1.5 to the x to the negative 1. They're the same thing as the function in your calculator. Either way, it'd be about 0.071. In my opinion, I think the first one is an easier option than the second one because I'd probably forget. But either way, it's up to you. But anyways, guys, we are done with this lesson. If you have any questions, again, please be sure to come see me for tutoring.